What does math and music shares in common? Find out the similarities between math structure and classical music. Part 1 of 5. Let's discover how patterns, harmony, and rhythm intersect in this captivating exploration. Classical music and math share several similarities, and their relationship can be quite fascinating. Let's delve deeper into the commonalities between classical music and math in terms of structure and forms. 1. Logical structure. Both classical music and math exhibit a logical structure that follows specific rules. In math, concepts are organized into logical systems, such as algebra or geometry. Similarly, classical music adheres to compositional structures like sonata form, fugue, or symphony, which provide a framework for organizing musical ideas. 2. Sectional divisions. Classical music compositions often consist of distinct sections, such as movements or variations, which are analogous to the different components of a mathematical equation or problem. These sections are interconnected and contribute to the overall structure and development of the composition, similar to how mathematical equations progress through different steps towards a solution. 3. Symmetry and balance. Classical music often exhibits symmetrical structures, just like mathematical equations often possess symmetrical properties. Composers may employ symmetrical phrases, themes, or chord progressions to create a sense of balance within a composition. This symmetry contributes to the aesthetic appeal and organization of the music, similar to how symmetry is appreciated in mathematical concepts. 4. Development and resolution. Both classical music and math involve the concept of development and resolution. In math, problems are presented, worked through systematically, and eventually resolved to reach a conclusion or solution. Similarly, musical compositions develop themes, motifs, and harmonies, leading to moments of tension and resolution, creating a sense of narrative and emotional impact. By the way, it's time to give your child the edge they deserve with Ailey's educational read. Subscribe now for foolproof learning and practicing strategies in piano and math. Invest in their future. 5. Transitions and modulations. Classical music and math both utilize transitions and modulations to move between different sections or key areas. In math, transitions occur when moving from one step to another, and modulations involve changing variables or parameters. In music, transitions and modulations help to smoothly shift between musical ideas, tonalities, or sections, ensuring a coherent and flowing structure. Generally, modulation is quite similar to setting the derivative, dx/dy, to zero in calculus. By recognizing these commonalities in terms of structure and forms, we can appreciate the inherent relationship between classical music and math. Both disciplines employ logical organization, repetition, variation, symmetry, and development, contributing to the intellectual and aesthetic aspects of their respective fields. Exploring these connections can deepen our understanding and appreciation of both classical music and math. Happy playtime, happy math time. This is your trusted piano instructor, Eileen. See you next time. Math and classical music are best friends? Find out the similarities between math structure and classical music. Part 2 of 5. The love-hate relationship between math and music. Get ready to be blown away by the amazing connection between math and music. Both of these incredible disciplines share a common bond when it comes to patterns and symmetry. Let's dive into this amazing discovery. Here's a further elaboration on this connection, along with 5 easy-listening classical pieces that exemplify the point. 1. Patterns. Mathematics and music both rely on patterns to create structure and coherence. In math, patterns can be found in sequences, formulas, and geometric shapes. Similarly, in music, patterns are prevalent in melodic motifs, rhythmic sequences, and harmonic progressions. These repeating patterns provide a sense of familiarity and order. Here is the easy-listening classical piece that is heavily involved with music patterns. Canon in D by Johann Pachelbel. This iconic piece features a repeating canon structure, where several melodic voices imitate and overlap each other in an intricate pattern, creating a mesmerizing and memorable composition. 2. Symmetry. Both math and music embrace the concept of symmetry. Mathematics examines symmetrical shapes, equations, and functions, while music employs symmetrical structures to create balance and aesthetic appeal. Symmetry can be observed in melodies, harmonies, and even the overall form of a composition. Here is the easy-listening classical piece for reference. Ein kleine Nachtmusik by Wolfgang Amadeus Mozart. This delightful serenade exemplifies symmetrical structures, with balanced phrases and a clear symmetry in the overall form of the piece, contributing to its elegance and charm. By the way, it's time to give your child the edge they deserve with Ailey's educational read. Subscribe now for foolproof learning and practicing strategies in piano and math. Invest in their future. 3. Fibonacci sequence. The relationship between math and music can be seen in the application of the Fibonacci sequence. This mathematical sequence, where each number is the sum of the two preceding numbers, 0, 1, 1, 2, 3, 5, 8, 13, and so on, is found in various musical elements. For instance, composers use the Fibonacci sequence to determine the lengths of musical sections or the number of repetitions in a pattern, creating a pleasing sense of proportion. Here is the easy-listening classical piece. Goldberg Variations by Johann Sebastian Bach. This masterpiece consists of a theme and a set of 30 variations, each showcasing Bach's ingenuity and craftsmanship. The variations, based on the initial theme, demonstrate the use of proportional patterns and intricate symmetries, highlighting the connection between math and music. 4. Harmonic symmetry. Harmony, a fundamental aspect of music, involves the relationship between chords and their progressions. In math, harmony can be understood as the balance and symmetry found in numerical relationships. Harmonic progressions often follow predictable patterns, such as the circle of fifths or the use of chord inversions, creating a sense of harmonic symmetry. Here is the easy-listening classical piece. Gymnopédie 1 by Erik Satie. This tranquil and contemplative piece showcases harmonic simplicity and symmetry. The repeating chord progression and the delicate balance between dissonance and resolution contribute to its serene and introspective atmosphere. 5. Palindromic structures. Palindromes, which read the same backward as forward, are found in both math and music. Mathematically, palindromes exist in numbers and sequences. Similarly, composers sometimes create musical palindromes, where a melody or a chord progression is reversed and played backward, adding a playful and intriguing element to the composition. Here is a list of easy-listening classical piece. Symphony 40 by Wolfgang Amadeus Mozart. The first movement of this symphony showcases a palindromic structure known as a crab canon. In this musical puzzle, the melody is played forward by one voice and then backward by another, resulting in a fascinating and symmetrical musical pattern. These easy-listening classical pieces demonstrate the interplay between math and music in terms of patterns and symmetry. By exploring these compositions, you can experience firsthand how mathematical concepts are translated into the enchanting language of classical music. Happy playtime, happy math time. This is your trusted piano and math instructor, Eileen. See you next time. What do math and music have in common? Cracking the Code, Mastering Ratios and Proportions in Mathematics, Part 3 of 5. Have you ever wondered how do the concept of ratio and proportion used in both math and music? Ratio and proportion. Mathematics deals extensively with ratios, proportions, and mathematical relationships. The connection between mathematics and classical music is truly captivating. In the realm of mathematics, ratios serve as a means to express the comparative sizes of quantities. Additionally, proportions establish equivalence between various ratios. These fundamental concepts empower mathematicians to analyze relationships and make predictions based on numerical patterns. In the world of classical music, ratios and proportions play a vital role in creating beautiful harmonies. Musical scales, for example, are constructed using intervals that adhere to precise frequency ratios like octaves, fifths, and thirds. These principles help achieve the harmonious sounds that listeners admire in classical compositions. In classical music, chords are formed by combining notes with precise frequency relationships. Through the use of mathematical principles such as harmonic progressions and counterpoint, composers craft intricate compositions that have the power to stir emotions within listeners. The utilization of ratio and proportion in mathematics and classical music serves as a compelling example of how these seemingly separate disciplines are intricately linked. It highlights the capacity for mathematical concepts to enrich artistic expression by infusing compositions with depth, beauty, and structure. While this post may be short, I genuinely hope that it will inspire you in some way. It's important to remember that even brief encounters can ignite a spark of inspiration. I eagerly anticipate our next interaction. Happy playtime. Happy math time. This is Eileen, your trusted piano and math instructor. Until then, see you next time. Precision, the key to success in classical music and mathematics. Harmony and precision, exploring the intersection of classical music and mathematics, Part 4 of 5. The power of precision. Unveiling the importance of accuracy in various disciplines. Precision and accuracy are fundamental aspects of both classical music and mathematics. In the world of music, performers must meticulously follow the notes, rhythms, and dynamics as prescribed by the composer. Every nuance and expression should be faithfully portrayed to convey the intended emotions. Similarly, in mathematics, precision is paramount in calculations and problem-solving. Even a minor error can lead to significant discrepancies in the final results. Classical musicians spend countless hours honing their technical skills to execute each note with utmost accuracy. They strive for perfect intonation, impeccable timing, and flawless execution of complex passages. Similarly, mathematicians rely on precise calculations to solve equations accurately. Both disciplines demand unwavering attention to detail and a deep understanding of their respective systems. In music, a slight deviation from the written score can alter its intended meaning or impact the overall harmony. Likewise, in math, even a small miscalculation can render an entire solution incorrect. For example, placing the decimal in a different spot creates a drastic difference. Furthermore, both classical music and math require discipline and practice to achieve mastery. Musicians dedicate countless hours to rehearsing intricate pieces until they can flawlessly reproduce them during performances. Mathematicians diligently work through problems repeatedly to develop their analytical skills and ensure accurate results. The pursuit of precision and accuracy in both classical music and math highlights their shared commitment to excellence. Whether it is hitting the right note or solving complex equations flawlessly, these disciplines demand meticulousness from practitioners. In conclusion, precision and accuracy form the bedrock of both classical music performance and mathematical problem-solving. Both fields require practitioners to adhere closely to established rules while striving for perfection in their execution. Whether it is creating harmonious melodies or solving intricate equations accurately, both endeavors exemplify the importance of precision as a guiding principle for success in these domains. Here are 3 piano pieces recommended for beginners to appreciate precision, accuracy, and synchronization in both piano playing and mathematical understanding. 1. Für Elise by Ludwig van Beethoven. 2. Minuet in G major by Johann Sebastian Bach. 3. Prelude in C major by Johann Pachelbel. Subscribe now to unlock all the secrets and stay ahead of everyone else. Happy playtime. Happy math time. This is Eileen, your trusted piano and math instructor. Until then, see you next time. student asked, "Can I learn music without actively involving my thinking?" The power of problem solving and creativity, breaking boundaries between music and math. Part 5 of 5. How can I determine the most suitable fingering for this passage? Problem solving and creativity are two essential skills that are not limited to just one domain. Math and classical music serve as remarkable examples of how these skills intersect and intertwine. In the realm of mathematics, problem-solving demands logical thinking, analysis, and the ability to find innovative solutions. Mathematicians explore complex equations, algorithms, and mathematical concepts to unravel patterns and solve intricate problems. They employ critical thinking skills to break down complex challenges into manageable components and then develop strategies to tackle them head-on. Much like a composer crafting a symphony, mathematicians use their creative abilities to think outside the box and devise elegant solutions that may seem unconventional at first glance. Similarly, classical music offers a platform for composers to showcase their creative prowess while engaging in problem-solving activities. Composers face various harmonic and melodic challenges as they strive to create original musical ideas that captivate audiences. They must navigate the intricacies of musical theory, experiment with different arrangements of notes, harmonies, rhythms, dynamics, and textures until they achieve a harmonious balance that evokes emotional responses from listeners. Just as mathematicians approach problems from multiple angles to arrive at a solution, composers explore various musical possibilities until they discover compositions that resonate deeply with their intended audience. Both math and classical music highlight how problem-solving requires more than just analytical thinking. It demands an imaginative mindset capable of exploring uncharted territories. The synergy between logic-driven problem-solving techniques in math and the artistic innovation found in classical music exemplify how creativity can enhance problem-solving processes across diverse disciplines. In conclusion, whether it's finding innovative solutions in math or crafting expressive compositions in classical music, problem-solving intertwined with creativity is an essential aspect of both domains. The ability to think critically while embracing imagination enables mathematicians and composers alike to push boundaries beyond traditional constraints, resulting in groundbreaking discoveries or breathtaking melodies that inspire generations. Here are 3 classical music pieces known for their extreme symmetrical structures. 1. The Art of Fugue by Johann Sebastian Bach. This monumental work showcases intricate fugues and canons, where the musical themes are developed symmetrically and systematically. 2. Symphony 4 by Gustav Mahler. Mahler's Fourth Symphony features a highly symmetrical structure, particularly in its use of thematic material and recurring motifs that create a sense of balance and cohesion. 3. Symphony 8 by Anton Bruckner. Bruckner's Eighth Symphony is renowned for its symmetrical architecture, with recurring themes and motifs that are skillfully developed and mirrored throughout the piece. These compositions demonstrate the beauty and artistry that can be achieved through the deliberate use of symmetrical structures in classical music. Just a friendly reminder. Subscribe now to unlock all the secrets and stay ahead of everyone else. Happy playtime. Happy math time. This is Eileen, your trusted piano and math instructor. Until then, see you next time.